Good morning. This is the Let's Talk Science session. And as I mentioned in an earlier session, the program committee tries to address three criteria. We try to bring in recognized experts on particular fields. We try to run NOVA, professionally programmed science programs. And we also try to encourage people from Horizon House who themselves have expertise and experience in certain areas to share those with us. And that's easy to do because we do have a lot of emeritus faculty from the UW. Gordon Orians fits into actually two of those categories, and he's always enlightened us and informed us about the complexities of evolution and the evolution of the Earth's ecology. The talk today reminded me of the three criteria for real estate: location, location, location. And Gordon is going to explain how that applies equally to the evolution of the world's ecology. Gordon.
I'm always amazed that people clap first. I guess it's an act of faith. You're encouraging me. Okay, I got it. I used to think it was great to be called an expert. And then I looked into the word more closely. And X is an unknown quantity, and a spurt is a drip under pressure. But anyway, it wasn't until fairly recently that everybody believed the Earth was flat, right? And that's the way it looks, right? And it took a long time before we figured out that this is what it is. This is what it is. This is the shape of things. And I think the most important photograph ever taken was one that one of the astronauts took looking at Earth out there. There it is, folks. That's it. And it's all we're going to have. And if you think we're going to have a wonderful life on some planet whose environment has no support whatsoever for life, I have a bridge in Alaska I'm ready to sell you. But anyway, I brought, this is Joyce's, and thank you, Joyce, because I encourage everybody, if you haven't done so for a while, to go look at a globe, because it gives you a different perspective. Because whenever you try to make a round thing flat, as I've gone up there, you got to distort. And this is the only non-distortion thing you're ever going to look at. And this shows you right away if they're going to travel, if I'm going to fly from Seattle to London, why I go over Greenland. That's straight, right? You can see that right away. You can never get it on. And when you see all of this, you notice that there's almost no land down below the equator there. It's almost all in the northern hemisphere. And in fact, if you look at this more closely, if you go to the latitude of Seattle in the southern hemisphere and go around, you're over water 98% of the time. 98%. You get a little bit of Patagonia and a little bit of the South Island of New Zealand, and that's all out there. So you've got and you see and this map actually shows it that it's very in the southern hemisphere. There's a blob of land right on the equator, the southern, and that's Antarctica, and it's completely surrounded by water, and you can go all the way around that, and the whales and the albatrosses do that. In the northern hemisphere, up at the North Pole, it's a small body of water surrounded by land with almost no connection to the rest of the ocean. The only significant one is the Gulf Stream going up past Iceland, and the rest of it is pretty isolated, so it's rather different. So it's worthwhile looking at a globe like this because you see these things, and you get a perspective on it that I think is better than you can get by looking at a map. But I had to choose a map because we're going to, I can tell you this and you can see it, but I'm going to need this map to talk about it. And this is the projection which gets, and you got to, like, what distortion do you want to live with? And the one I want to live with is it's going to get worse as you go toward the poles. And this one is, because the longitude lines come together, right? But this one, they don't come together, they stay flat, which means that in this map, Greenland looks as big as Africa, which it isn't. Whatever its geopolitical importance, is not nearly as big as Africa. So I'm going to set this down because this gets in the way, but I'll invite you to come up and have a look at it afterward, because you see the world differently, and that's the way it really is. But meanwhile, so I'm going to use this map, and there's Antarctica. It's all over the place there, but it's true. It covers the pole there, and there's mostly water up above. This also shows you how huge Asia is. It's huge. We'll come back to that, and so I will make use of this periodically. But there's a couple other things I have to mention first. And that is, although one of the most famous books ever written is called The Origin of Species by Means of Natural Selection, it's the most badly titled book probably in history. He doesn't talk about the origin of species at all. And there's a wonderful field, speciation, and I could give a whole talk about how speciation occurs, and it occurs differently in different plants and animals and all that sort of stuff. But we need to know just what I'm going to be talking about: birds and mammals, including us. And how do new species form? Well, basically what it is that you have to get some split in a population, so it becomes isolated into two segments, either because a barrier is imposed because somebody migrates, and so then they evolve separately in their new environments with not exchanging genes. And slowly the differences accumulate, and it may, after a while, it may be so much that they can't interbreed, or they're not interested in interbreeding, and we have two species. So we're going to be talking about speciation, and in birds and mammals it takes big space and it takes a long time. And that's not true everywhere. Plants can happen in one generation and all that. So leaving aside plants, because we're not going to go there today, except as an aside. So speciation is an important thing, and there's been millions, and as far as we can tell, life evolved once. We all got the same stuff, all species using the same genetics and everything else. So there were at once very, very few species. Now there are millions, and the millions of others have gone extinct. So this has been happening all the time, and it influences what we're going to look at. And the other thing is, I have to talk about climate, because I'm talking to a bunch of people who live on the Pacific coast who have a very blinkered view of climate. You think that winter is supposed to be wet and summer is supposed to be dry, right? Wrong. That's a very, very, very rare climate on Earth, and it occurs in just 5 places, always on the west side of continents, where you got cold water flowing toward the equator, okay? And we can go into detail later if you want to why that. So that means you've got 5 places on Earth where that is: the Mediterranean basin, where it gets its name, the Pacific coast of North America, and then 3 places in the southern hemisphere. In Chile, which is the mirror image of California, and around Cape Town, the southern part of Africa, and southwest Australia. And these latter 2 places have the most fantastic vegetation on Earth. And if you got to go to South Africa to see it. It is absolutely unbelievable. So there's these 5. So what is it normally like? Mostly, the most precipitation occurs when the sun is heating the place the most. So I grew up in Wisconsin, southern Wisconsin. What's the wettest month in southern Wisconsin? June. I've done a lot of work now in eastern Montana bringing the bison back. And what's the wettest month in eastern Montana? June. Think about this. In the the way to think about it is in the tropics, where the sun is going back and forth overhead. So the heating, although it's pretty hot always, you're going to have a maximum heating when the sun is right overhead. And then the sun, as we see it, that isn't how it happens, but that's how it looks to us. So then the sun goes further to the north, and the rain belt goes with it. And then the sun comes back, and then the rains come, and then it goes down to the southern hemisphere, and it rains there. And so the pattern, if there were uninfluenced by anything else in the tropics, you would have two rainy seasons. One following the passage of the sun going north, with a little bit of lag, because the thermal mass of the Earth always takes a little while to heat up. And that's why we have the longest days in June, but typically the hottest weather is a month later. And we have the shortest days in December, and typically the coldest, on average, the coldest weather is a month later, because the thermal mass of the Earth, it lags by, and it takes a while to heat this big thing up. So typically you would have in tropics then 2 rainy seasons as the sun goes back and forth. And the one last big migration of terrestrial mammals that takes place in the Serengeti depends upon that. They're down in the southern part when they give birth, when the rains are down there. They're able to move north a little bit toward Lake Victoria, which creates its own rain and gets up to the Masai Mara in Kenya, and it's rainy season up there. So they're tracking the rains. They're going back and forth, following the rains. And it happens to be a short enough distance that migrating mammals can do that. And that's the only place left on Earth where it's like that. There was one exactly like that in mirror image in South Africa, where you had around Cape Town, the winter wet, and then you go up to the Okavango, and it's summer wet up there, and you had migration going back and forth. And that was killed by Europe. Europe decided we're not going to allow imported beef from South Africa unless you keep them separate from wild animals. So they built a big fence. And millions of big zebras and wildebeest and springbok died on the fence, and we totally wiped it out. It's too bad. It could still be, and I think this would be the most magnificent regeneration project we could have. The species are still there. There are not so many of them, but they're still there. And we could do it, but don't stay tuned. I don't think we're going to do it. So, remember then that thinking about rain, think of when the sun is overhead and heating it the most. That's over most of the world, that's when it's wettest. And I rather like the summer dry, but that's a really small thing. So these are some background things that we're going to use. And I'm going to talk from now on with this map, which we know what the distortions are, but they don't matter right now for my purposes. But Antarctica looks really fabulous there, doesn't it? But it is right there at the center. Okay. So now I'm really going to talk about biogeography, and I want to start with Asia, because with the old world, because Asia is enormous. It's really big. And it's going to have an impact on world climates. But there are 2 other continents, Australia and Africa, that are there, and this interplay. And then you see you've got this enormous dry belt that shows up yellow there, which is the desert area going across things. And that's the biggest arid areas in the world, and this has important implications. So we got this huge mass of Asia dominating things. And so think of this then. In summer, this huge mass gets warm. It's a long 24-hour sunshine, and it gets really wet. And it develops a huge uplift. The sun is really powering things up. And so it's saying, and it pulls in moisture from everywhere. And this is what gives you the Southeast Asian monsoon. That's what causes it. It's rising air over Siberia, in comes the moisture, and you get this most stunning monsoonal climate on Earth. And then in the winter, that gets unbelievably cold. The coldest weather in the world occurs in eastern Siberia in the winter, far from the ocean. And huge masses of dry air come out of Asia over the Himalayas and down into southern Asia, and creating very different conditions than at other times of the year. And the human exchange between Africa and Asia was based on those winds. And they hadn't learned how to sail into the wind, so you had these dhows that traveled between East Africa and India, so they could make one trip a year. They could go up from Africa to Asia in the summer when the winds were out of the south, and they came back a trip in the winter when the winds were out of the north. So you had this exchange. And Lamu, if you've ever been to these things, Lamu was the place where all this took place. But you could only do it once a year. This big thing also has this huge thing, has an influence on rainforest in Southeast Asia, because you get a big influx of cold air at some in the winter that triggers mass flowering and wind pollination in Asian rainforest trees, which is totally different than anything that occurs anywhere else. And so Asian rainforest trees have a very different ecology from those in the New World, and it's because Asia drive this. And Asia also has a big effect on the African climate, because East Africa is on the equator there. It should be really wet, and it's not. Why is East Africa so dry? Again, it's Siberia. It's the pole. It pulls moisture that should be going, it pulls it away. And so there's just a little bit of wet on the coast of east of Kenya, a little bit. It doesn't penetrate it in because it's all being sucked into by the great Asian powerhouse. So East Africa is a lot drier than it ought to be because of Siberia. So this huge land mass has an enormous influence on world climate, but it's also have had enormous influence on human history, because you can see up there, you can walk back and forth, and that's what people did. There was called the Silk Road, and it was about 1200 that Marco Polo was going back and forth there, and you could walk back and forth, and it was fairly dry. You didn't have to have a major rainforest you had to cross. And you could do it without any real change in latitude, so that it was an easy adjustment. And so this connection back and forth across Asia and to Europe. But in addition to the silk, which they really valued, there's some other stuff came. But other important thing that came was disease. Diseases came along with this. And most of the diseases that people had were related to having domesticated mammals. And almost all of the major diseases that we developed had their origin in domestic mammals. Well, that was great in Europe, but in the Americas, they didn't have them. The biggest domesticated animal that the Aztecs had, the turkey. You didn't get any diseases from turkey. Now, South America was a little bit different because you had some camels. There were two species of wild camels, the guanaco and the vicuña. And from each of them, we got a domesticated mammal, llama and alpaca. They're wonderful. They could carry a lot, but you can't ride one. They're not big enough for that. So in 1491, everyone who traveled anywhere in the New World walked. There was no other way to go. You walked. And that influenced a lot. So And it was isolated. Marco Polo could get across because you had domesticated mammals. He could ride camels and horses and stuff. You got in the New World, you had to walk because you didn't have a mammal that you could ride. And so this was isolated and isolated the populations into small units. And they didn't know what was going on elsewhere. They didn't know about one another. And the small size meant that you didn't develop diseases, and so resistance to diseases. So when Europeans came, we just clobbered all the New World people. And one of the biggest things that most of the native people of the Americas were killed by disease, not being shot. And this is one of the unfortunate things, but that's the way it is. So this huge Asian landmass has affected all sorts of things, including the climate of Africa. But it's also important for biodiversity because you've got this huge, well, let's back up a little bit. The mountains, as I said, in the old world all run east and west, and the Himalayas run roughly east, a little bit trending south. But the Himalayas are rather low latitude. A mean latitude of the Himalayas is about the same as Miami. This is really low latitude. So the south side, you drop into India there where it's hot. And even you get some cool weather in the winter, but it's a pretty hot place. And the speciation of birds along the Himalayas is related to the fact you can just go up and down. And the far western part of the Himalayas is arid. And as you come further east, it gets wetter. And so there's speciation of a lot of stuff of birds along that, like there's 4 nuthatches in all of North America. There are 8 species of nuthatches along there. And there are pheasants and various birds. It's really, really wonderful. But also, this means that there's this huge area you got this huge mass of land up there with birds, particularly in the summer, flocking in there. It's just wet, wonderful insects all over the place. And if you've ever been in the boreal forest in North America, you know you better have mosquito dope on or you're going to eat them alive. This is wonderful stuff. But where do you go in the winter? Where do you go in the winter? Let's look at the eastern thing there. You've got a couple places. You can get down into India a little ways. And that's what the cranes do. And but you also have the opportunity. You could go to Australia or Africa, and let's look at these places. Australia turns out to be a non-player in this, except for migratory shorebirds, curlews and godwits and stuff like that. The Australian beaches are full of those in the winter, but almost nothing else comes in. And Australia is a continent of impoverished soils, all those beautiful sandstone cliffs. They're sterile. It's awful stuff. And intense fires. And Australia burns all over the place. And if you're interested in all of that, I did give a talk here a number of years ago, and it's available on HH Connect, called Australia Without the Sydney Opera House. And if you think you know Australia because you see the Sydney Opera House, forget it. It has nothing to do with Australia. And besides, the acoustics are terrible. You would never build an opera house that shape. And actually, many, many years ago, my wife and I did go to a performance of La Traviata there, and it was awful. It was really awful. I guess they've done some things to shape, but you would never build a building like that for an opera house unless you wanted to have a building to show off, which is what, of course, it is. So Australia, it's hard. A lot of birds having trouble breeding, and it's a terrible place to go. So almost nothing. But the only birds that migrate into Australia in the summer are some parasitic cuckoos. And there are a lot of cuckoos in the world, most of which are brood parasites. That is, they laid their eggs in the nests of other birds and let the other birds raise them. And a bunch of cuckoos come in from New Guinea in the winter, the bird. But almost nothing else goes from Asia, goes to Australia. So the big player is Africa. And look, Africa is magnificently positioned there. It straddles the equator, but other things interesting are important. It happens to be where human beings evolved. So we've been there for a long, long time. We haven't been elsewhere in the world I'm talking about for very long. And one of the things that happened is that we evolved then together with the big grazing mammals that characterize it. We all know about Africa, that you go to Africa to see, right? And these are things that, and Africa soils are not very, very good either. But what you do if you have big mammals and they're grazing and knocking the grass back and pooping and peeing on it and creating a fast cycle, and you create a very active and vigorous ecosystem. And you can do this because unlike most of the other plants we know, the growing tip of Africa is of grass is at the bottom, right? It's at the bottom. That's why when you mow your lawn, you don't kill it. Because as a matter of fact, you stimulate growth when you mow the lawn because you open up the sunlight and it gets down to there. And if you let it cover up, and if grasses aren't grazed, it gets a dense thing and it smothers it. And the place where the growth would be doesn't get any light and it stops. So grasslands are much more productive if you have large grazing mammals on them. And so the mammals are creating the richness. So it's either, and sometimes fire can do the same thing. And Aborigines have used fire a long way to try to mimic this. But so Africa, even though the soils are basically poor, you have this combination of big mammals and human beings interacting, creating a rich environment. So an amazing number of the birds that breeding up in Asia go to Africa in the winter. They travel, of course, around and come down to Africa. And my favorite one is a bird that is called the red-footed falcon in Africa, and the Amur falcon in northeast China. And this Amur falcon breeds in northeast China and Siberia there. At the end of the breeding season, they fly to India and sit and tank up a little bit. And then they fly across the Indian Ocean to South Africa, where they winter. And then in the spring, they go back. This is an amazing migratory pathway. And that's because the best place for falcons like open country. Africa's full of that. It's pretty arid. And in part it's arid because of Asia, as we've just talked about. So that's a wonderful place. Asia has about 12 species of eagles. We got 2. That's part of this big east-west. A very big fraction of them winter in Africa. We got a little migratory, the wheatear, which is a common breeder in Arctic Alaska. Where do they go back? Down, they winter in North Africa. So there's a tremendous amount coming in. So the big biogeographic pattern we see is that for migratory stuff, it's dominated by Africa. But because it's low enough, we've got 6 species of cranes there, and they just go, none of them migrate. There's cranes in Africa, but they're not migratory from Asia. And they're just able to cross the Himalayas a little, and they got small ranges, and they're all endangered, all got tiny populations, but they go back and forth and they're spread out. We got 2, and we'll say a little bit more about that. So that whole spread across Asia gives you enormous biodiversity, and an awful lot of the survival of that over the year is dependent upon the availability of Africa as a place to winter, and that was dependent upon the fact that there were big mammals there and people. And the big mammals and the people evolved long enough that they figured out this funny little ape was actually something to be afraid of. And so it evolved a fear of human beings, so that there wasn't a mass extinction big mammals. Everywhere else in the world where human beings showed up and they hadn't been before, we wiped them out. There was, or big birds as the case. In New Zealand, there were the moas and huge things, but some of them were bigger than ostriches. But when human beings came, they just Maori mouthed their way south across New Zealand and ate them up and exterminated them. And there were no other native land mammals other than bats in New Zealand. So when Captain Cook arrived, what were they eating? Cannibalism. That's all that was left. That was all that was left. Pretty. Got to Madagascar, which was populated not from Africa but from the east. There were elephant birds bigger than, there was a terrestrial hippopotamus. There was a lemur as big as a gorilla. When the people arrived, they're quickly eliminated. They're gone. So this is it didn't happen in Africa because it was slow enough when we were there, as we figured out how to hunt, and they figured out that the funny little ape that walked upright was something to be afraid of. And nowhere else did they figure it out in time. So Africa became available, and this combination meant that even though it was relatively poor soils, you got this cycle going and peeping and pooing and everything else, and made it really productive, and it's a wonderful place to go. So Africa has a huge role to play now, and it has for quite a while, in the migration in from Siberia, where the things go in the winter. And this is the story of why Africa is so important. So I started with the old world because this Siberian landmass has this enormous influence. But let's go to the new world. And it's skinny, as you see, and all the mountain ranges run north and south. The old world, they're east-west, right? No, these are all north and south. And it's fairly skinny, so that any migration along the mountain ranges means you're changing latitude very quickly. And that involves a lot of complicated genetic changes in any organism. You could go back and forth on the Silk Road and you didn't have to do that. You weren't changing latitude. It was easy adaptation. All the things in the New World are going north and south. And you're any movement, you're changing latitude, and you got to deal with circadian rhythms and all sorts of genetic stuff in organisms. So it's very different in the New World with all of this, and it's skinny. So the connection between the New World and the Old World is all at Alaska, at the northern tip. And at times it's been a land bridge, as you know, you can walk across, and times it isn't, like now, depending on sea level. But all the connection between the old world and the new has been at the Arctic. And that's why it's interesting that which birds have gone back and forth. We got one lark now in North America, the horned lark, and it's the only Arctic breeding lark. And Eurasia is full of larks, lots of different species, dozens and dozens of species. We got only one. And which one did we get from Asia? The Arctic breeding one. And it's now spread out all over North America, and it exists in environments and adapting to different environments, which would probably be populated by at least a dozen species of larks in the old world. And as a matter of fact, our horned lark is undergoing some pretty rapid and wonderful evolution. And I got if you're your bird guide, I brought one here with the tab there. Got a whole page full of horned larks. They're different, and they're in the process of differentiating, and the differences are big enough that the field guide's got to show them, it's rather interesting. The other thing that we got a shrike. A lot of shrikes in the old world, none in the new world. We got one shrike. It's the only high latitude breeding shrike that came over, the great northern shrike, and it has speciated in North America, north-south, a northern shrike and a loggerhead shrike, and that's the two we've got. But again, the shrike is from the Arctic, the most high latitude breeding shrike of the old world. Going the other way is the wren that has got the highest latitude breeding, the winter wren, which is now subdivided, but it goes way up into Alaska. It's crossed over the land bridge into Asia, and it's all across Eurasia. And in Britain, of course, they just called it the wren, because there wasn't any other wren. Well, the New World is full of wrens. We got 6 species here in Washington. Mexico, I think, has got 24 species of wrens. It's a New World bunch, but only one got across. So there's been very limited exchange between the New World and the Old, and it's been at high latitude. Cranes came in that way, and we've got only 2 species of cranes in the New World, the whooping crane and the sandhill crane, whereas we got 6 of them across Siberia, spread out. But it's interesting what's happened with the sandhill crane that tells us something about speciation in North America. It's widespread over, and it's in a lot of different. There is a non-migratory population in eastern Cuba, genetically rather distinct. It's evolving something new. Unfortunately, it's probably going to go extinct before it gets long enough to be a different species. If you go and look at the cranes in the big migration across Nebraska, you see that there are 2. There's a greater sandhill crane and a lesser sandhill crane. They're very different in size. And the lesser sandhill crane is the Arctic breeding crane. And it breeds all across the Arctic and into American Arctic and into Siberia. And it's small, and that's why it can breed in the Arctic. If you're bigger, it takes longer to produce a clutch. The incubation, this period is longer. Raising the babies takes longer, and there isn't much time up there. And so that the small sandhill crane is the Arctic breeder, and the one that breeds down at lower latitudes is big. And that's true of other stuff. The Canada geese, the Arctic breeding Canada geese are not much bigger than mallards. They're tiny little things. There's not much time to get it done up there. And if you've been up to the Skagit and watched the snow geese, they're small, right? They're not very big compared to the big Canada geese that may be around. Because our snow geese breed on Wrangel Island off the north coast of Siberia. And there's a short season there. And it used to be, early days, when it was still colder, you could watch the snow geese coming down to the Skagit, and you could tell if there's any babies because they're gray. If there were a bunch of gray ones, that means they raised some babies. And there were years when they came back with no babies. It was total the snow folded in and shut things down before they were able to fly out. Recently, there's always babies. If you go up in the winter in the sky, you'll always see baby gray snow geese because they make it every time now. So, and this is important to remember, unlike the southern hemisphere where there isn't much land and it doesn't get cold, we have this big land mass at high latitudes and it gets really cold. We have very, very cold winters. And I'll deal with that as we come to southern South America, which gets to high latitudes and doesn't get cold winters. So a lot of places where things are breeding today, they weren't able to breed 10,000 years ago. We couldn't have had this meeting here 10,000 years ago because under a lot of ice. So all of the stuff where we're seeing now, remember that this is all spread out. in the last 10,000 years. And that has created a lot of interesting stuff. And this is what's still going on very actively. And it's easy to think of, what we're seeing now is the way it's been. Well, it hasn't been that way very long. And this is a big thing in the northern hemisphere that has affected things that is not the case in the southern hemisphere. So our mountains, as we've seen in western North America, happen to get a lot of winter snow because we got this rather peculiar climate right here that really dumps a lot of snow. And the Himalayas didn't get that because it was winter dry, summer wet. So you had all the stuff open up, and it was easy to colonize, and you didn't have to wait for a lot of snow to melt. But there's another place in North America that I want to mention briefly that is rather different and an area of rapid speciation and interesting stuff, and that is Mexico. Mexico has two mountain ranges, east-west, and it's low enough latitude that things don't have to migrate out. And so you've got, Mexico is a biodiversity-rich place. There are more, I've once saw in the Yucatan Peninsula, 6 species of orioles in one flowering tree. That's more species of orioles than there are in all of South America. The center of speciation in orioles is Mexico. For thrashers and mockingbirds, that's a big speciation place. For warblers, Mexico is biodiversity rich, and there's a whole bunch of endemics. Wrens, there are wrens all over the place. Vireos, there are some 20 species of vireos in Mexico. We got 2 here. So Mexico is biodiversity rich, and it's possible because the mountains there are low enough latitude that you don't have a big winter freeze out, and you got to migrate, and so it's been able to do really interesting stuff. So Mexico is a fantastically interesting place, and also you get high mountains, and really high mountains just west of Mexico City, where you got a spruce fir forest. That's where the vast majority of the migratory monarch butterflies from eastern North America spend the winter. And amazing, they have flown down from the Great Lakes region in southern Canada. They've flown all the way down there. Why is that such a wonderful place to spend the winter? Because it's cold enough that you'd both burn up. They got to fly back to the Gulf states in the spring, not having fed. So if it's warm, you burn up faster because the insect's body temperature goes what it's. And so it's cold enough up there that you don't burn up your energy, but not so cold that it freezes you out. And if you have one of the most remarkable things to see is these fir trees hanging with millions of monarch butterflies. It's one of the great. It's because of the peculiar climate conditions that are there. But let's move on to South America, which is absolutely fascinating. And South America has this continuous high mountain range that goes from a little bit north of the equator in Colombia all the way down to Tierra del Fuego. And it's continuous, the longest continuous mountain range on Earth. And throughout that area, there is land above timberline. Land above timberline, all the way across that. And it changes because right at the equator, it's wetter, as we would expect. As you get away from the equator, it gets drier. But this continuous, and it's been a speciation route there. But I need to mention one other thing I forgot. I'll go back. South America has been isolated, one of the most isolated continent throughout history. It was not connected to North America. The Panamanian land bridge, which connects them, developed less than 4 million years ago. Until that time, South America was a totally different place, and it developed all its own stuff. About 4 million years ago, the land bridge developed, the Panamanian land bridge, so mammals could walk back and forth across, and they did. It's called the Great Panamanian Exchange. And stuff went in both directions. And South American mammals, as you now see, is heavy with stuff that came from the north. Peccaries, the deers, the cats, the dogs, everything. South American mammals community today is loaded with stuff that walked across the Panamanian land bridge over the last few million years. Some of them came north, but they didn't do so well. And there are only 4 species of mammals in North America that are the result of South American mammals crossing the land bridge and making their. 3 of them occur here in Washington, or did. The one which is widespread all over North America is the Virginia opossum. It's a marsupial. It's not well known, but 1/5 of all the world's marsupial species are in South America. There's a big marsupial fauna there. But they didn't do anything spectacular like kangaroos and wombats. They're all sort of opossums related. But there's a pretty water possum, pretty interesting. But there's a lot of marsupials in South America. Only one made it up over most North America. South America was full of what we call hystricomorph rodents, and they're very different rodents from the. They were much more like hares. Hares have they have big babies that are small litters and big babies that hop around right away. That's what the hystricomorph rodents of South America are. They tend to be big. They tend to have big babies, and so they're more like hares than they are like rodents as we think of them. But you have this very rich rodent fauna, and there's what we sometimes call the Patagonian hare, which is a hystricomorph rodent. The world's largest rodent, the capybara, is like the South American hippo there. And the hystricomorph rodents that you would be most familiar with is the guinea pig, and that's typical. Have big babies, and so South American rodents were very, very different. And they didn't do so well coming north, but one of them did, and it spread all over the boreal forest of North America. That's the porcupine. And we've got it here. And they're in the Cascades in eastern Washington. It's spread out in the boreal forest, and it's why. But that's the only one of the hystricomorph rodents that made it up in North America. Another species that has made it is the armadillo. There's a bunch of armadillo-like things, sloths and other stuff in South America. And one of them made it, and it's pretty widespread across southeastern U.S. And the last one made it for a while and then didn't last. And that's the giant ground sloth. They got here, they're in the bogs in western Washington, they're dug up. It's a huge, it was a magnificent ground sloth, a huge animal that could grab stuff. And it had incredible claws, and it was perfectly good at defending itself against any other kind of predator, lions or stuff like that. You could rake it. It was absolutely helpless with a silly little ape that could throw spears. We did it in, but it didn't last very long. And they went extinct too in South America because we're the kind of predator that they had no defense against. And this is one of the latest. We've been, in many ways, the great exterminator. And this is one of the most spectacular ones that it would kind of be nice to have giant ground sloths around, but they didn't make it. So this exchange has had a different effect, dramatically affect South American mammals. Almost no effect in North America. They didn't make it. It didn't have a big deal for birds because the Panamanian land gap was not that big. Birds could go back and forth. But it's important to remember the Panamanian land bridge. Remember, someone's bridges is someone else's barrier. So what this has done is separate the marine fauna on the two sides of the Panamanian isthmus. And so now you see speciation is going to start to develop, and the scientists at the Smithsonian Tropical Research Institute in Panama are studying this. I hope they still get a chance to do it. But we know roughly when the break occurred and how long these things have been involving differences. They cut it off. There's no exchange anymore. They can't get through Panama Canal because it's fresh water. Okay, and the marine stuff can't handle fresh water. And that's why a sea level canal would be very different. But this is a freshwater canal as gravity flows. So marine mammals don't get across the Panama Canal because they can't stand fresh water. This kills them right away. So it's still a barrier. So remember that someone else's corridor or someone else's barrier. It's always the case the way it goes. So South America has had this rather interesting history, very complicated. And the one thing that did get there early, we don't know how it got there, are the monkeys. That's a real puzzle. South America has monkeys that are very different from the old world monkeys. They've been there for a long time, and nobody knows quite for sure how they got there. But South America is the bird continent. It is more species of. Colombia has 1/8 of the world's bird species in that small place. And what's going on is that you've got mountain, and since it's tropical, not big, things don't have to migrate in and out, so things can go just up and down. And these mountain ranges on the Pacific side, it tends to be very arid, and on the Atlantic side, it tends to be very wet. And so this has been an amazing speciation factory, and South America is the bird place, and I could go along all the wonderful stuff about the birds, but going all the way down to Patagonia, the last bit down there, nobody has to migrate out. It doesn't get cold. It doesn't freeze. You got little steamer ducks down there. One of them is flightless. You got geese down there. It doesn't create anything. It's been a wonderful speciation place. If you go down there in the winter, if you're lucky to get around, you can see 20 species of sandpipers and plovers and curlews that bred in the Arctic to spend the winter down there. But now, and some swallows. Your barn swallow, your local barn swallow may be there, but in the winter. But it doesn't generate a lot of stuff. Peru has almost no birds in the winter that are coming out of Patagonia, and so it's a wonderful place down there, and I could spend a lot of time talking about it, but I am running out of time. So, as the Bible says, the first task God gave to Noah was name all the animals. Now they thought Noah could knock that off in a couple of hours. And here we are. We haven't named half. We don't know how many there are. We don't know. Haven't described most. Many of them are going extinct before we have a chance to even know what they are. And interestingly, Noah wasn't asked to name the plants, which is curious. And the ark, he wasn't asked to put any plants on. And somehow the plants were supposed to survive inundation, which will kill them. But it's an interesting thing that, maybe this was pretty good because they recognize that if Noah had to bring on oak trees and pine trees, this would pose a real problem for the ark. But so he didn't have to do that. But so here we are. We haven't described but a fraction of the animals and plants that are on Earth. As Aldo Leopold said, the first rule of intelligent tinkering, save all the pieces. And we are massively losing the pieces, and we don't even know what the pieces are. They're going away, and we don't seem to care. And I just hope that if 30 years from now you invite a biogeographer to give a talk, and she could say, wonderful, there are still six species of cranes in Asia. And of those 12 eagles of Asia, 11 of them are still around. But I don't know what she's going to be able to say. And what she might be able to say depends very much on what we're going to do. And unfortunately, I don't think we much care about that right now. But I hope that you would be able to hear 30 years from now, there are still six species of cranes in Asia.
We're running close to the end of the hour. Those of you who do have to leave, feel free to go ahead.
I'm
those
sorry,
of you who would like to,
I talked too long.
No. Those of you who would like to stay and ask questions, please, we'll do. We have several people running around here with mics, and here's one right back here already. Go ahead.
I'd like to ask about northern pachyderms. And there are pachyderms.
Yeah.
There are theories that say it's climate primarily that did away with them, and others say it was humans. But you're talking about the mastodons and.
Well, yeah, we know that there were woolly rhinoceroses and mastodons all over in the Arctic, and the latest ones were on an island off Siberia that went extinct not too long ago. So we had these huge mammals in the Arctic, and there's a lot of debate about this, but the hypothesis that I tend to favor is that just as the mammals create this thing in East Africa by pooping, they created the savanna, the Arctic savanna. The mammals did it by grazing, opening it up and let the sunlight come in, pooping and peeing over the place, and creating a system that was productive because the mammals created it. And there's an experiment going on in eastern Siberia now, a man by the name of Sergei Zimov, who's trying to recreate the Pleistocene steppe there using the mammals that are still left. And he's brought in some horses and bison and elk and deer, and is working on to trying to let the mammals create this and show that that's what did it. Of course, part of the demise of the mammals is, of course, that we killed them all off too. But so there's a mixture that I tended to favor the hypothesis that the fact that you could have elephants and rhinoceroses up in the Arctic is the fact that they created the environment that made it possible. The fact that they're not there is us. Does that answer you? Okay.
Gordon, I have a question. You're talking about the mountain ranges usually going north and south. But what did you say about the mountains in Mexico? Were they east-west?
No, they're I'm sorry, I wasn't clear about. The Mexican mountains are mostly north-south. They're trading a little bit southy, but it's mostly north-south, yeah. So you have different weather on the two sides of them, yeah. They're mostly north. And you got two, Sierra Madre Occidental and Oriental. So you've got two separate mountain ranges that come together down around Mexico City in the big west, but mostly there's two very different mountain ranges. And that's what makes Mexico so diverse.
What effect did the blackbirds have on the indigenous species of birds when they were introduced? Allegedly, America had no blackbirds.
Who had no blackbirds?
The American continent, the New World,
Yes.
did not have blackbirds until they were introduced by somebody from England, because they wanted to have all the birds that are mentioned in Shakespearean plays.
Yeah, that's true, but those did not involve blackbirds.
Okay.
The blackbirds, the icterids, are native to the Americas, found only in the Americas.
Huh.
So we brought in some birds yeah, it's true that the Brits decided that any place that didn't have all the birds mentioned in Shakespeare was depauperate. That's how we got starlings. That's how we got house sparrows.
Oh,
and so,
okay, starlings.
But blackbirds,
Yeah.
we had, and the Brits in October go down to the southwest coast after a storm, hoping to pick up an American stray blackbird.
Starlings, I meant starlings. So the starlings, what effect do they have on the birds?
So the starlings
What is
are a
it?
member of a family of birds that's widespread in Europe and Asia. They have had an effect on birds in America, and the primary reason that they're hole nesters. And the way we manage forests is not to let them get big enough to develop holes. And so there's a shortage of holes, and they've been competing for holes. And so the way they brought the bluebird populations, which are big affected by starlings, is to develop a birdhouse, and they define if you get the right side hole, the bluebird's a little bit smaller. The bluebird can get through, and the starling can't. And they put these house and brought bluebirds back by this method. But starlings seem to be declining. The diseases are picking up. There's not as many as there used to be, and they may be picking. One of the things that when you travel across the world, you're likely to leave your diseases behind, and that's what. But the diseases are slowly catching up to the starlings now.
Joyce?
I have an observation. Looking at the United States with Alaska, the Gulf of America, Canada, our 51st state, and buying Greenland. Wow, what an empire.
Yeah.
Look at the landmass.
Yeah, it's obviously it's tantalizing to somebody.
Where did the bison come from?
But bison came over from Asia, because there's a European bison, the Wisent, which almost went extinct, and it's now being rehabilitated. It's quite a different animal. It's a forest animal and a browser. Ours is a plains animal, and we had a big Pleistocene. Before human beings arrived, we had an amazing array of big mammals in North America. We had different species of bison. The pronghorn, which is the last surviving member of a family, the Antilocapridae, where there were dozens of species. It's the last one that made it. There were lions, there were cheetahs, there were camels. North America had an amazing fauna, big mammal fauna. And again, what happened to them? Homo sapiens arrived. They're all gone. One left, one pronghorn, the one thing left. There were dozens of species of those. And the reason the pronghorn is so fast, it's the fastest animal in North America, it was preyed upon. We had a cheetah, which chased them. We had lions. I didn't go into that much, but again, the cause of extinction is unfortunately very clear. We did it.
Any other questions? Okay, I guess we'll wind it up. Thank you very much, Gordon. Thank